Hello, grade 1 teachers. Let's have a look at some ways that you can connect computer science into your matter unit. Your computer science curriculum talks a lot about instructions, the ability to follow instructions, create instructions, and discuss and use instructions in a variety of contexts. This allows you to make lots of connections to computer sciences throughout your daily activities and routines. In addition to teaching computer science explicitly, you'll have all of these extra opportunities to connect it to things that you're doing with your class so that they can further understand the overall idea of computer science around creativity, design, and computational thinking, and give them the skills that they will need to move up through the grades and continue to learn through this organizing idea. Design thinking is one of those common threads that goes all the way through kindergarten through grade 6 computer science. We have ways that we can apply this daily throughout our other class lessons. Students might not necessarily talk specifically in grade 1 about the process of design thinking, but just encouraging the different steps along the way and really having students think about certain things like empathy and understanding that sometimes the first time we try something it doesn't work and we need to try it again. At grade 1 level, learning those concepts connected to design thinking is going to help build those skills as they move up and also make them really good problem solvers. Also, computational thinking is one of the threads that's carried all the way through that computer science curriculum, as we've seen. And we'll look at some ways that you can specifically address computational thinking and ways that you'll be using it just by the design of other activities throughout your matter unit as well. And we want to always encourage students to use their creativity. It is a part of this organizing idea, along with computational thinking and design thinking, is the idea of using creativity. And they talk a lot about using creativity to solve problems and the different ways to reach the same outcome. So really just encouraging students to look at things in different ways is a way to encourage that creativity. And we'll see ways to use that all throughout our days and classroom routines, as well as within our teachings, including our matter unit. Let's jump in and have a look at a few specific ways that we can make some connections to the skills and procedures within the matter unit. I've pulled out skills and procedures because they are the things that the students will be doing, so it's simple to connect in the computer science ideas with those things that students will be doing. So when the students are identifying measurable properties of objects and comparing objects, length, weight, and all of those things, they are using their computational thinking skills. They're looking at specific properties, so we're kind of decomposing the properties of those things. And also, we have a specific skill and procedure from computer science in grade 1 that is about following instructions with 2 or 3 steps. So when you're giving students instructions for an activity regarding these or any of the skills and procedures within your matter unit, if you've given them something that's 2 or 3 steps to follow in order and they are doing that, they are demonstrating this computer science outcome right at the same time. If we were to give students, whether it's a digital version like this or an actual selection of objects, and ask them to start talking about the size of these objects and how we might start grouping them up, and we might talk about what are our size words, and we could start to think about which of these might we consider small and which are we going to consider big. And we can tie in computational thinking. As soon as we start to break something down, we're looking at just the size of these objects. That's the only attribute of them that we care about at this point in time because we're trying to meet a size outcome. And so the color of it doesn't matter. Its purpose doesn't matter. None of the other attributes that these objects have matter. We're only looking at one. So we've worked through that decomposition, pattern recognition, pattern abstraction through discussing what is it that we're looking at about these objects? What's going to help us make this decision? Let's get rid of everything else. It doesn't matter. We're only considering size. Now we could go to that fourth step with the algorithm development by coming up with some conditions or rules around those size words. And again, we're connecting into this specific skill and procedure, but we're also really connecting into that organizing idea of computer science and specifically the computational thinking. So we could use a sort of a grid layout like this or some other way of measuring with probably non-standard units in grade 1 and then come up with well how do we decide what is small or large? Maybe when we sorted in the previous activity, you put something in the small category that I put in the large category. So maybe we need to come up with some sort of a rule that determines what it is that is large, and then we could come up with as a class or ask the students to create these a set of rules, essentially algorithms that would explain how we can tell. Now I could give this to another person, I could give this to a machine, and they would be able to sort any object they came across by following these rules. So that's a way that you can connect that computational thinking nicely into that matter, skill, and procedure as well. So there is those objects sorted out, small and large now by our definition. And again, this might be something we're doing digitally like this. Maybe we're doing it as a class at the front. I'm giving the students an example. Maybe they have physical things in their hands and they're doing this on the floor and using some way on the floor to measure. However they're doing it, we now have created those rules and we're applying them to objects. I'm going to actually just flip back for 1 second. And then we could also continue to take this to the next level and continue with that abstracting by asking students, what else belongs in these categories? And maybe we have determined that there is a rule. These are all things we use in school, but can we think of other things that we use in school that would fit into either of these categories? And if we haven't determined that rule, well, then we could think of all kinds of things probably that would fit into these things. And now we would be applying that rule into some new ideas. You will see my KidBot pop up a whole lot during computer science videos and sessions that I'm doing. When I see all of the skills and procedures and the knowledge and understandings around following instructions, particularly in the lower elementary grades, I see that I would be incorporating this language into my classroom all of the time. So if we're doing any kind of a science experiment, like we're covering this skill and procedure here about using various tools safely, there is an outcome right out of the computer science that talks about following instructions during investigations. And the knowledge connected to this one actually talks about safety in investigations too. So following instructions to be safe. So this is definitely a case where we are covering these two at one time. And by just simply asking the students to tell you what steps they're going to follow to complete this investigation, they're going to be covering the computer science outcome. And then by completing that investigation, they're doing the skill from the matter unit as well. You can use the algorithm language, the computer science, computational thinking language anytime with your students when you're talking about instructions. And you can reference how you have given them a set of instructions, just like an algorithm, and they are programmed to run it just like a machine could be. And you can always be incorporating that language throughout your days. So, further to that, just some more of the matter skills and procedures that are really getting deep into specifically your matter content. And depending on how you're going to do these with your students, you can easily be making connections, as I've mentioned previously in this video. Anytime you've got them working through that design process, again, maybe not talking about what the steps are, but if we're thinking about other people, if we're empathizing, if we're planning out a different way to do something, we are ideating. If we're testing something out in science, we're doing that testing piece. So we can make those connections. Again, the kid bots, anytime I've given you instructions, it can be instructions for any of these science investigations, activities, or lessons that we're doing in class. If you can follow them, you're meeting a computer science outcome. If you can have the students come up with the steps, tell them what the end goal is, that they need to create something or explain to you in a certain way, or tell another student or tell their parent or tell someone else how to do something that also achieves one of these skills and procedures, then again, you're doing that computer science skill while you're covering that. And then there's the opportunities for just sequencing some instructions in order. So again, you're giving them an activity. Instead of giving them their instructions in the proper order, give them to them mixed up and ask them, what do you think is the right way these are supposed to be, before starting the activity. And now you've hit that computer science skill there as well. And you can likely make connections for them as well in the same way, giving them a set of instructions, throw in something that doesn't belong in those instructions, have the students figure out if that should be there, give it to them in a different order, or have those conversations when you're doing these things, working out what do you think our steps are for this activity, investigation, lesson, whatever it is that we're doing. What is the order? Do you think it matters if I do this one first and then that one? And maybe we test it out even to just see, does it make a difference? And then we're hitting all of these pieces of the computer science curriculum along with covering those science and matter. So those are some ways that you can connect your computer science into your matter unit as well as throughout your other teachings. I hope you enjoyed.